Most of my work involves nature, geology, technology, and ideas of space and time and distance and collapsing distance. Most of my works have involved collaborating with people in different fields and disciplines.
We're all astronomers, so we look at things through a particular way, through a particular methodology. Having Katie in the corridor has brought sort of a whole new life to the place. Seeing her interacting, talking to students and staff and getting ideas and giving us some ideas has been very fruitful. It turns out we live in a rather dark universe. In fact, 96% of it is dark. And we belong to the 4% of ordinary matter. That is to say, matter made of atoms. We at University College London are heavily involved in the Dark Energy Survey. It's a way of generating a new camera, in fact, one of the largest cameras in the world, to actually learn about the contents of the universe, the amount of dark matter, the amount of dark energy. This has already stimulated Katie to think about the history of darkness.
I've been collecting images of darkness from throughout the universe, kind of spanning the history of the universe. It is an ongoing slide archive that I'm going to work on for ages probably, because it doesn't in a way have a beginning or an end. I think quite a few of my works kind of loop and circulate and inform one another.
We are busy producing a set of measurements and building a camera, and she's looking essentially at the same universe, but with a different point of view.
The scientists were very much used to framing what we understand about the universe in particular ways and very specific ways. So perhaps suddenly to have the opportunity to think a bit more freely about our own subject, I think Katie's been able to encourage us to have the courage to do that a little bit more.
The other piece that I've made is called 100 Billion Suns, and that is a confetti cannon. There's 3,216 pieces of paper, and they each correspond to an explosion called a gamma ray burst. And when it burns, it burns as brightly as 100 billion suns. It shines so brightly, it outshines the whole galaxy, the brightest explosions to happen in the universe. So I've collected and sourced all of these 3,261 images and colour matched them and made this confetti cannon. So now when it's exploded, it's a bit like a tiny explosion of all these universal explosions that happens, but making it a 1 second moment here on Earth.
There are different ways for a celestial object to end its life, whether it's a black hole or gamma ray burst or supernova, and in a way it's not really the end of life, because stars, as they explode, they spread around them gas which by itself is the ingredient for the next generation of stars. So it made me think more philosophically about the kind of work we do.